The title is about the living environment and immune response, and I've been studying whether we can say there are causalities or if they are just correlations. Here you can see a typical urban environment in a highly developed country. It's the city center of Helsinki, as you know, and it's pretty safe for infants and children. It has not earlier been so, and this is in 1930s. My father is crying. He's the second from the left. My grandmother gave 17 births, and my father is crying because mother didn't cut his curly hair. He thinks he looks like a girl. And the elder brothers had very short hair. They were at school and they wear lice every once in a while, so this is why they had short hair. And there were also other pests were common. So the environment was very different. And if you look at the feed, so every step they took, they received billions of environmental bacteria and probably also some pathogens. And as a result, if you look at the steadily increasing queue, you see gaps. It's because of child mortality. When Finland urbanized after Second World War, so child mortality decreased, and now Finland is one of the best countries in terms of child mortality. You can see it from these maps. These are global maps, and you can see that globally child mortality is still decreasing. At the same time, in those countries where child mortality is exceptionally low, so non-communicable immune-mediated diseases, their frequency is exceptionally high. There are two examples of that. Atopy is one of those diseases. It's very common also in Finland. And it has been suspected that it's because of the lack of biodiversity, environmental microbial biodiversity. And if we think about soil, a typical gram of forest or agricultural soil, it contains more than 1 billion bacteria and a rich network of other microbes. At the same time, when children receive brand new sandbox sand, it contains maybe 10,000 or 100,000 bacteria per gram. And when they play with it, it may contain 1 million bacteria, not 1 billion, so a fraction. Now, I salute late academic professor Ilkka Hanski and also Tari Hahtila. Together with their collaborators, they published a paper about the association, the correlation between atopy and land cover surrounding birth addresses of children in Finland. And they observed that forests and agricultural land, if there's plenty of forest or agricultural land, so it's associated with low probability of atopy. And in contrast, if there's plenty of built environment or water bodies, it's associated with high probability of atopy. If the yard contains plenty of flowering plants, so the probability of atopy is low. And finally, they interestingly found that the number of genuses of skin gamma proteobacteria, so it's so if it's high, so then the probability of atopy is low. And due to this and other studies, we started to study if indoor transfer of environmental microbiota is similar in urban and rural landscapes, and we compared very urban and very rural houses. We installed doormats in the front doors. We collected dirt for 2 weeks, 4 times a year. And we observed that urban summer maximum in the transfer of environmental microbiota indoors is as low as the rural winter minimum. We studied senior citizens and also children. And with children, there's this deep cohort, diabetes prognosis and prevention. So it consists of 15,000 children, and we did similar study than what Hanski and Johtava had done with atopy. And we observed that when the birth address is surrounded, this is how we took different circles, and we observed that the development of type 1 diabetes was delayed in agricultural environment. But this was also an association. This is not necessarily a causal effect. So it's just association that children who live in countryside, for some reason, they development of type 1 diabetes was delayed. And these were risk children. They had genes that increase the risk of getting type 1 diabetes. Okay. Then we started to think how to bring this indoors. We cannot change urban environment, so at least not totally so. So we tested what happens if volunteers are in contact with soil. First, it was just a short-term trial, and we observed that skin microbiota was 10 times richer, and there were much more microbes on hands after hand wash if they first were in contact with soil, only for 20 seconds. Then we repeated this for 2 weeks, and we measured skin microbiota before and after the trial, but it was not the same spot where people were in touch with this. This was highly biodiverse soil mixture, so we selected soil, commercially available soils that we knew had a high biodiversity, so microbial diversity. And what we observed was that after 2 weeks, in the intervention group only, skin and stool microbiota, they explained immune response. But this was the first experiment. There were less than 10 participants in both groups, so it was a very small scale trial. But still, I think it was highly interesting. Okay, now let's go back to urban environment. This is a playground in Finland. This is in Germany. This is in Greece. This is a schoolyard in USA. And as we can see, they are environments where it may be hard to find microbes. In fact, usually there is less than 1,000 bacteria per gram soil, if there is any soil on those rubber or asphalt or concrete plates. And if we think about climate, so when this environment is moist, there is microbial activity, but it dries very quickly. And unfortunately, as a result of climate change, so the extreme weather conditions and dry spells and dust storms, they are becoming more frequent and more extreme. So it is likely that the possibilities of children to be in contact with environmental microbiota are smaller than nowadays in the future. And this is why we wanted to introduce green environment to those yards. So we had 7 daycare centers in Finland, and we did daycare yard rewilding in 4 of them, and 3 were controls. We inserted transferable forest floor, lawn, and the children had planting boxes, and we followed them for 1 month in both types. We had also positive controls, so nature daycare centers where children go to nature every day, or actually forest is next to the door of the daycare center. And what we found, this experiment took place in spring in May and July. So in the intervention daycare center, it's on the left. So the skin gamma proteobacterial diversity, it remained high, it remained rich, it didn't decrease as in the standard daycare yards, which are in the center. And so children in nature-oriented and in intervention daycare centers, so they had similar skin microbiota. And this gamma proteobacteria, it's the same taxon that was pointed out by Hanski and Hartela and collaborators. And we also monitored bacterial and gamma proteobacterial diversity and richness at yard surface. And we observed again that it was higher in the end of the trial, so in the intervention daycare centers, while it was quite low in standard daycare centers. So you can see here both soil gamma proteobacterial and soil total bacterial diversity and richness. And finally, we studied immunoregulation. And we found that the change in skin gamma proteobacterial diversity, it was associated with immune response in the intervention yards, so among children in the intervention yards. If you look at these slopes, so the red one, which is control, it is not significant, while in the blue one, which is in intervention daycare center, so it was significant. This one is the frequency of regulatory T cells, so in blood. We also saw that the ratio of 2 interleukins, an immunoregulatory interleukin 10, it's IL-10, and pro-inflammatory interleukin, it's IL-17A, so it increased in the intervention group, but not in the control group. So this also suggests that as a result of this intervention, the immune regulation of daycare children was enhanced. And since this is an intervention study, so it is hard to explain this being just a correlation. It's probably a causal effect. But in this case, when you receive something beautiful, when your graveyard is substituted with a green paradise, so it's basically possible that it's the visual effect. It's not the microbiota, and this is why we did a placebo-controlled, double-blinded, randomized trial. So we installed sandboxes in the daycare centers. There were different daycare centers. And the sandboxes contained normal sand, but we enriched it with peat, which we knew is quite poor microbiologically, or we enriched it with the biodiverse mixture of different commercially available soils that I talked earlier. So we had a biodiversity arm and we had a control arm. And then children were supervised for 2 weeks. So here you can see the assistant who took care that children were in touch with the soil for 20 minutes 2 times a day. And we saw changes in skin and gut microbiota in the intervention arm, in the intervention group, not in the control group. We saw a shift in interleukin-10 as in the earlier trial. It's actually here. And we also see a similar shift in the ratio of IL-10 and IL-17A as in the earlier experiment. This is probably the... Yes, so the conclusion was that immune regulation enhanced. So this is the summary of all the trials we have done so far. So we have always seen a change in immune response, even in a currently unpublished trial where we did indoor cultivation. It has not been peer-reviewed yet. But this is short term. The interesting thing is whether this leads to lower probability of getting a disease. We are having a long-term trial where children, infants receive lotion and biodiversity in pockets, in hats, and in sheets. We don't know what are the results. It's going on. And then we are also having long-term outdoor trials. And we will get the results in a couple of years. The second purpose of these outdoor trials is to see how this affects, how rewilding affects urban ecosystems, and whether it can mitigate consequences of climate change, because it basically decreases the heat extremes. This was the last slide. Here are the thanks. I want to mention Martin Romanchuk, who supervised me during my postdoc years, and well, here are the other persons. Thank you.